welcome back to another week of Pre-Algebra on BCPS-TV. I'm Stemmers Run math teacher, Mr. Gordon. These lessons are for the week of May 18th, and we'll start with Lesson 1, Volume of Prisms. Okay, so for Lesson 1, we're going to have two objectives. The first is for students to use formulas to find the volume of triangular and trapezoidal prisms. And our second is for students to use formulas to find the volume of composite polyhedrons. Okay, so those lesson objectives may have had some vocabulary words you weren't familiar with. The first of which may be a polyhedron. So a polyhedron is a three-dimensional figure in which all surfaces are polygons. So if you look over here to the right, we have 5 different polyhedrons as examples, and you can see all of their surfaces or all their faces are going to be shapes you're probably familiar with. Two-dimensional shapes like a triangle or a square, or down here this fourth one, they're all 5-sided figures which are pentagons. So a polyhedron the term comes from 2 different parts. So the first part, poly, means many, and hedron means faces. So all these shapes over here to the right are going to have many faces. And that's your definition of a polyhedron. All right, so now we got to look at this difference between what we call faces and bases. All right, so the faces of a polyhedron are the flat surfaces that make the shape up. So as you can see here, this is going to have 5 different faces. This is what we call a triangular prism. So we're going to have 3 rectangles and we're going to have 2 triangles that make up the total faces of this shape. Now, specifically, 2 of these shapes are called the bases. So in this case, notice I called it a triangular prism. The bases are what we use to name the figure. So the triangles represent the bases because they are actually the parallel faces of the prism. If you look at it in this 3-dimensional shape, you'll see this is again an example of a triangular prism, and as we look at it, you'll see it's made up of 3 rectangles and 2 triangles. This triangle here is considered one of the bases because it's going to be parallel to the triangle you see coming up here now. All right, so it has 5 total faces. 2 of the faces represent the shape's bases, and that's how we name the prism. So this is a triangular prism. Okay, so there are 4 really key volume formulas you'll need for this first part of the lesson. The first is a rectangular prism. This is one hopefully you're familiar with from 6th grade. That one is volume equals length times width times height. Our cube, the volume is we take one side length, all the side lengths are going to be the same, and we take it to the 3rd power, or we cube a side length. A triangular prism and a trapezoidal prism is going to be volume equals area of base. That's why it's a capital B, because it's the area of base times height. And now, if you recall, a triangle has a area formula of 1/2 base times height. A trapezoid has an area that's 1/2 the sum of base 1 plus base 2 times height. We're going to break each one of these down a little bit more. One thing to pay special attention to is you're going to have this idea of 2 different heights. So you're going to have your height of your prism, but you're also going to have your height of your 2-dimensional base. And we'll break those 2 heights down as we go through a couple examples. All right, let's start with kind of a review on to warm you up a little bit. So this shape here is going to be a rectangular prism. And what we're going to do is we're going to find the volume. So we're actually going to find the space inside of this 3-dimensional shape. So since it's a rectangular prism, I'm going to use my formula volume equals length times width times height. I'm going to substitute in my 3 numbers, which represents my length, my width, and a height. Because multiplication is commutative, the order in which I sub these in really doesn't matter. So I'm going to multiply 8 times 2 times 5, which is going to give me 80. So I would say the volume of this prism is 80 centimeters cubed. Notice my units of measure now have switched from squared when we were doing area to units cubed now that we're doing volume. All right, so we're going to take a look now and switch gears a little bit. We're going to move from the rectangular prism to the triangular prism. So for this one, we're going to use a different formula. We're going to use volume equals area of base times height. You'll see why I have that capital B in red in a couple of seconds. So recall that capital B means we need to find the area of the base. So as I look at the base of this shape, I see it's a triangle. So I'm going to replace the capital B with the formula to find the area of a triangle. So notice now it becomes volume equals 1/2 base times height times another height. So this is where, if you recall in the formulas, I said you got to pay attention to two different heights. So the second height is the height of the prism. The first height is the height of the triangle. So when I'm going to sub in, I'm going to color code for you. I notice the height of my triangle is 11. That's right here. But the height of my actual prism is 15, which is right here. So I'm paying attention to two different heights. All right, now I'm going to put this in my calculator. I'm going to multiply 13 times 11 times 15. And then to multiply by 1/2, I can also just divide by 2. So if I do that, the volume of the prism is 1,072 5/10 feet cubed. All right, it's your turn to show what you know. You're going to find the volume of this triangular prism. I will give you 1 minute. Okay, let's recall this is a triangular prism because it has two parallel bases that I'm attempting to highlight here that are triangles. So hopefully we use the formula volume equals area base times height. We're going to replace that capital B with 1/2 base times height since our base is a triangle. I have a triangular height of 7. And I have a prism height of 22. All right, so now multiple ways I can do this, but again, I'm going to multiply 24 times 7 times 22, divide by 2, giving me the volume of this prism is 1,848 meters cubed. All right, let's take one look at a trapezoidal prism. So again, what makes this a trapezoidal prism is I see bases here and here, which are trapezoids, and they are parallel. All right, so the start of this formula is going to look very similar. It's area base times height. Truly all volume is area of base times height. It's just we change what the area, we change the formula for the base because as the shape changes, the formula changes. So in this case, we're going to sub in 1/2 the sum of base 1 plus base 2 times height in for capital B, the area of the base. Also remember, the second h that we're going to multiply is actually the height of the prism. All right, so as I take a look at this, I see base 1 is 8 and base 2 is 5. Or you could switch them around and make 5 base 1 and 8 base 2. I'm going to sub them in for B sub 1 and B sub 2. And I see the height of my trapezoid as 5. So all of those go in to the equation. And then the height of my prism is actually 6 3/10. So if you look at the color coding here, everything in that greenish color applies to capital B, and everything in red applies to the prism. All right. If, again, follow the order of operations, use my calculator if need be. I'm going to do what's inside my parentheses first. So 8 plus 5 is 13. Now I'm going to multiply these three totals and divide by 2, giving me 204 and 75 hundredths, making the total volume of this prism 204 and 75 hundredths centimeters cubed. Okay, so let's look at our second objective for this first lesson, and that is to find the volume of a composite polyhedron. So if you recall from last lesson, we talked about the idea of something being composite, being made up of more than one thing. So if you look down here at this shape down here, you can see we have multiple three-dimensional shapes making up this larger shape. So I got to observe some things first. So the first thing I'm going to notice is that the rectangular prisms on the left and the right are congruent. And then I have one small different rectangular prism here in the middle. All right, so I kind of like the idea that these are all rectangular prisms because I'm only going to use one formula for this whole problem. So again, I got two congruent rectangular prisms, one other rectangular prism in the middle. So I got to really do two different problems here. So both will use volume equals length times width times height. For the larger ones, it's 3 by 3 by 4. And for the smaller one, it's going to be 2 by 1 by 1. So this represents the smaller rectangular prism in the middle. This represents the two larger congruent rectangular prisms on the ends. So if I multiply them, I get 9 times 4, which is 36, or 2 times 1 times 1, which is 2. I'm now going to add the 3 together. So I got two rectangular prisms that were 36 feet cubed. I have one that's 2 feet cubed. If I add them all together, I get a total of 74 feet cubed. All right, our second lesson for the week of May 18th moves us to the volume of cones, cylinders, and spheres. Okay, we have two lesson objectives for lesson 2. The first is students will use formulas to find the volume of cylinders, cones, and spheres. And in the second objective, we'll find the volume in real-world context. Okay, so our vocabulary for these objectives are centered around 3 terms. Our cylinder is a 3-dimensional figure with 2 parallel congruent circular bases. A cone is a 3-dimensional figure with 1 vertex and 1 circular base. And a sphere is a 3-dimensional figure with all points the same distance from the center. So what you'll kind of see here compared to our last set of 3-dimensional shapes, these all obviously incorporate in some way, shape, or form something that is circular. All right, so if you'll recall, I mentioned before that all volume is area base times height. We just replaced capital B with whatever the formula is for the shape of the base. So for a cylinder, again, we got this idea of capital B. But remember that the area for a circle is pi r squared. So the formula is going to become volume equals pi r squared times the height of the cylinder. All right, let's take a look at our first example. So we need to find the volume of the cylinder to the right to the nearest tenth. So we're going to now use area equals pi r squared times h. We're going to take our diameter here, which is 6 4/10 centimeter, and we're going to cut that in half because we need a radius. So we're going to replace that with 3 2/10. The height of the entire prism, of the entire cylinder is 13 centimeters. So that's going to replace h. Be substituting for h in my formula. All right, so now again, all calculator work here. I'm going to square 3 2/10, multiply it by 13, and I'm going to use my approximation of 3 1400ths for pi. That's going to give me this long decimal 417 and 9,968 10,000ths. I do need to round my answer to the nearest tenth. So that 9 in the hundredths place is actually going to round my answer all the way up to 418. So the volume is about 418 centimeters cubed. Notice I have switched to about. Anytime we use pi, it's an approximation when we use 3 1400ths. So we're really close to what the volume would be, but this is actually an approximation because we are using circles and we cannot get that exact value for pi. Okay, it's time for you to show what you know. You're going to find the volume of this cylinder to the nearest tenth. In this case, they have given you the radius and not the diameter. I'll give you 1 minute to see if you can figure out what the volume of this cylinder would be to the nearest tenth. Okay, so hopefully you used volume equals pi r squared times h. We're going to sub in 4 for our radius, 12 for our height. We're going to use 3 1400ths for pi. When we multiply those together, we get 602 and 8800ths. And now we're going to round to the nearest tenth, bringing the volume of this cylinder to about 602 and 9/10 feet cubed. All right, let's move our attention to the cone. So the cone has a similar looking formula to that of the cylinder, but instead of doing pi r squared times h, we're actually going to take 1/3 pi r squared times the height of the cone. The reason we're going to do that is a cone will have a volume that is exactly 1/3 a cylinder with the same height and radius. So to put that in maybe easier terms, when you have a cone, you're going to do exactly what you would do for the radius, but you would divide your final answer by 3. All right, so let's take a look at our first example. So we need to find the volume of this cone, and we're going to round again to the nearest 10th. So when you take a look, we're going to see a lot of similarities to our formula, pi r squared times h, except we're going to only use 1/3 of that because we have a cone and not a cylinder. So our radius is 2. Our height is 8. Again, we're going to approximate 3 1400ths for pi. So if I do 4 times 8, I multiply that by 3 1400ths, and then I divide by 3, I actually get this repeating decimal. That's why you see the repetend bar over to 3, so that thousandths place repeats. So if I'm rounding to the nearest tenths, however, I'm going to get the volume is approximately 33 5/10 cubic inches, which is just another way to say inches cubed. All right, so we looked at the cone, we looked at the cylinder, now let's look at the sphere. So the sphere is going to have really a vastly different formula. So the sphere is 4/3 pi r cubed. If you take a look, some things to note down here at the bottom. The fraction is now 4/3, not 1/3 as in the cone. There is no height that you see in a cone or cylinder, and we are actually cubing the radius and not squaring it like we do with the other two shapes. All right, so let's look at a problem in a real-world context. So soccer balls come in several different sizes. One soccer ball has a radius of 11 centimeters. We want to know the volume of that soccer ball. We're going to round our answer to the nearest 10th and use 3 1400ths for pi. So one of the key components of this is this idea that the radius is 11 centimeters. That's really the only bit of information I need for the sphere. So in a lot of ways, it's an easier formula to work with. So we're going to say volume equals 4/3 pi r cubed. We're going to sub 11 in for the radius. And now we're going to, after we cube 11, we'll multiply by 3 1400ths. The easiest way to deal with this 4/3 is to multiply by 4 and divide by 3. Again, we get a repeating decimal. So the volume of this soccer ball is about 5,572 5/10 centimeters cubed. All right, unfortunately, we are out of time for today. Hopefully you enjoyed finding the volume of some of these three-dimensional shapes. Until next time, be good, and we will see you next week.